There are some important ratios in instrument transformer, and these are very important. First one is transformation ratio. What do you mean by transformation ratio? Transformation ratio is the ratio of primary phasor by secondary phasor. For CT, it is a ratio of primary winding current by secondary winding current, and PT is a primary winding voltage by secondary winding voltage. Now, second one is the nominal ratio. What is the nominal ratio? Rated primary winding current divided by rated secondary winding current. For a CT, we know there are some limitations of current. This is the manufacturer specifications for any transformer. So this is the maximum current that can pass through a transformer. Rated primary winding current divided by rated secondary winding current for a CT, and rated primary winding voltage by rated secondary winding voltage for PT is a ratios. This is known as the nominal ratios. So it depends on the rated values of current for CTs and for PT's rated voltages. Next one is the Tran ratio. In the first year also we know that the Tran ratios is equal to N1 by N2 is equal to V1 by V2 or is equal to E1 by E2 is equal to I2 by I1. So Tran ratio for CT it is defined as the ratios of number of turn of the secondary, number of turn in the secondary winding by number of turn in the primary winding. And for PT, number of turn in the primary winding by number of turn in the secondary winding. So we will remember all these things, that is the transformation ratios, nominal ratios, turn ratios. Another one is the RCF, ratio correction factor. Ratio correction factor of a transformer is defined as the ratios of the transformation ratio and nominal ratio. The RCF is equal to R by KN. Next, what is the burden of a transformer? Burden means it's the loading. Loading, that is the secondary terminal, one load is connected. So, in simple word, burden is the load connected to the secondary winding in volt amperes. The rated burden is a volt ampere loading which is permissible without error exceeding the limit of the particular class of accuracy. The burden is equal to secondary winding current square I square R into impedance of load on the secondary winding. So I square R, secondary winding current square into impedance of load on secondary winding. This one is the burden.